All right. Or if I'm Matthew McConaughey. All right, all right, all right. Let's get started. So I did grade the homework, right? So here I found out that apparently 1600 isn't the exact value for this. So if I misgraded yours because I said the one input was wrong, let me know. I'll regrade them. But apparently it's what, 1609 meters in a mile. I guess I was mistaken on that. So we have this example where I just use the different types, right? So miles to meters, miles to feet, miles, meters to miles, right? So we got 4 different conversions that we could do. And if you only do these, right, then if somebody enters feet to feet, right, it's just going to convert it, right? It's going to do nothing to it, so it'll print off the right result. You could have used switches. So again, this one's not particularly difficult. Are there questions on this? I tried to provide a rubric, so hopefully that gave you feedback, and if I took some points off. I still had people who would turn in something like homework 1 is the name of your class, right? And I have to rename it. I took off points for that, right? It says in the document you need to name it exactly this, so please make sure you do that, or I'll still take off points. Otherwise, I ran it through all of the tests that were given, and then I gave it one extra test, right, that was testing I think I did miles to meters was the additional test that I did. So, any questions on that? One other thing is some people only did, again, don't just do all of the runs that I do as one single run of your program. Right? You need to make sure that you solve the problem generally so you can run it 3 different times and get the correct output for each one of those. So I did have some people who still did that, and that is not the solution. So any questions? I'm recording this, so you don't have to take a picture of it. You can look through it all. All right. So what did we talk about last time? Does anybody remember? The front row is very leery to do it, so you guys in the back have opportunities because they don't want to answer the easy questions. Methods. Somebody said methods, all right? Yeah, so we talked about methods. What are the parts to a method? What do we have to do in all of our methods? Public static, correct. Where does it go? Does it go right here where I got my cursor? No. Where does it go? Somebody said inside. They whispered inside. It's inside something. I can put it here, right? Right, so remember, right, it has to be inside of the curly brackets to define your class. But it can't be inside some other method, right? So make sure you don't do that. So we got the public static. What else do I need? What's the next part? Return type. So let's say I want to do double. Okay, what's the next part? Well, arguments are coming. It's like winter, it's coming. What else do we need? A name, right? Okay. Then parentheses, and inside the parentheses we give as many arguments as we're going to have. We can have 0, we can have 1, we can have 20, we can have 100. If you have 100, that's probably too many. Just saying. Okay. So, right, we can call this method from within main. How would we call this method from within main? Just say its name, right? I would call that method. So what I'd like to do today is do some example methods. As you can see, I wrote the word convert. If you're also paying attention, you see that this says physics methods is the name of the class. So clearly we're going to do trigonometry. No, we're going to do physics, right? So I pulled up a bunch of physics formulas, right? So these are for physics of kinematic, right? Motion, right? Acceleration, things like that. So we are going to give it a bunch of arguments, right? So it's pretty easy to see that they've given us all of the variables that we need to put inside of our method. And then the result is going to be the thing that's on the left-hand side there, right? So let's start with V, right? That one shouldn't be too hard. If I can make this all fit on one screen. So we can read it all. So we can say, I'll just call this get, if I can spell right. Okay. And we can name things like, well, I'm going to assume that everything that we're going to do at this point is going to be doubles because, right, we can have, acceleration, gravity, 9.8, right? So we're going to be dealing with doubles at this point. So we got a double V0. Well, let me do that. Is it going to complain? Yeah, it's fine. Now it's complaining because, well, I haven't returned anything, right? Yay! And now this is going to complain, right? Because how many arguments have I given it? Anybody? Bueller? How many? You guys can do it. How many arguments did I pass in there? No, I say that I need 3, but how many did I actually give it in main? None, right? So it's complaining because I haven't given it anything. It's okay. We'll come back, right? You guys are lucky, right? At least it's telling you this, like, when you're typing. Like, when I used to do it, and granted, it was way nicer when I did it than when Sharam or Sherry had to do it, or John. But, like, we would have to, like, write our program, and then we'd do this thing called compiling it. And then it would tell us, oh, there's 100 errors. And you're like, what? And you fix one line, no errors, right? Because it would, like, mess everything up after that. So it tells you, like, hey, there's something wrong on this line, and not 100 lines later. So things have gotten a lot better. So how do we get our result? Shouldn't be hard. Equals what? V0 plus acceleration times time. All right. Okay. So we can pick our thing. So let's say we want to do so now what I call this? How do you think I call it? I changed the name, so it's very confusing. You can do it. Come on. What do you think? What's my first argument? Initial velocity. Okay, second argument. What? A, there we go. And then T, right? Oh. And I changed my method name. That would also help. There we go. So we can get that result. I can't DOU. There we go. We can print it off. So how would we print this off using remember? Who's not in the front row? Percent what? All right, dot 3, because we want to be different. What do I need after that? F? All right, let's see if it runs. Runs. Yeah, man. Having a bad day here. All right, so I didn't like our, so one of the things you'll learn, you get these nice stack traces saying where it failed. It failed on line 19. Missing format width. Another number in front of the period. Oh. Like that. Like that. There we go. 0 means you do leading 0. You can do leading zeros, I guess. Maybe not in this one. Huh. All right, so we got, right, if we accelerate for 9.8 at an acceleration rate of 9.8 meters per second, I'm assuming meters per second. I start at 0 and I fall for 1.2 seconds. I end up going, let's see, 11.6 meters per second is my speed. Right? Velocity is meters per second. All right. That one wasn't too bad. Let's do the next one. What do I need to do? You guys are the experts. I'm only going to type what you tell me. Okay, I'll pick it for you. Get displacement. Right? Delta X displacement. That's good. It's very verbose, but very good. What do I need now? Round curly brackets? Round brackets. Yes, parentheses. What are my variables? I'm just typing what you tell me, man. Yeah, good. Good catch. I was gonna not type the comma if you didn't tell me. What else do I need? Okay, put the comma in because you got to figure it out. Okay. What else do I need?
Double time.
Double time. So now I got to speak really fast. Now what do I need? Curly brackets. Very good. There's probably an actual name for them that's not curly brackets, but I go with curly brackets. Now what?
You have to return a result, so you make something equal, a double equal 0.
I'm just going to do it on one line. That's good. Result is equal to what?
Parentheses, B velocity plus B0. And outside parentheses, by B0. Times time.
Okay. Around the division, well, that's fine. I tend to do that also. I think it would probably be okay because, right, it shouldn't matter the order which I do the division and the multiplication. But in other ones, we might want to do that. Okay? So down here, I'll help you out. So I want to get displacement. So let's see. We will pick a initial velocity. All right, so let's say that's 0. A final velocity. Ooh. Okay. So there's some song, but I'm in a hurry to get things done. He goes 0 to 60 in 5.2. So our time is going to be 5.2. And how fast is 60 miles an hour in meters per second? We're going to figure that out. Let's see. 60 miles is a mile every minute, right? So 5,280 feet every 60 seconds. So every second, 88 feet in meters. Uh-oh. 88 feet. What's the feet to meters? You guys did that. Oh man. Okay. 26 point. What'd you say? Oh, we'll go. That's enough places there. We could also be lazy. 60 miles per hour in meters per second. Let's see if we did it right. There we go. We did. Is that what you Googled or oh, you did. So we did our conversions right. All right. All right. All right. All right. Ah, that's great. Okay, so let's see what his displacement is. And I'm good at copy pasting, so So if you accelerate from 0 to 60 in 5.2 seconds, you would go 69 meters. That doesn't seem like very many. Seems like it would be farther than that. But. Okay. All right. Let's do number 3. So change in x is velocity 0 times time plus 1/2 at squared. Are we getting the hang of methods here? Yes, yes. Okay, public, static, double. This one's also get displacement, right? We're getting delta x. What?
You don't have to name it something different. Does that matter?
So here's the rule. You can name 2 methods the same thing, but they have to have different number and or types of arguments, right? So the way we think about it is this method, and you go in order, right, takes 3 doubles, right? So I can't have another method that has the name get displacement that takes 3 doubles. It can take 2 doubles. It could take 3 doubles in a string. It could take 2 strings, right? So they have to be different. Like you have to be able to tell which one am I going to call. The only way to know that is if there is some difference in them. So, and this is called a function overloading. So we give the same name to a function that might do something different. So, if we give it different arguments, let's see, how many arguments do we need in this second one? We got v0, we got time, we got acceleration, well, we got 3 things, right? What are the types for all of those? We've been doing doubles. So, make one afloat. That would be one. We can make time afloat. There we go. We are correct. Okay, we'll be very creative, right? You can name it whatever you want. Right, it says displacement, but this one is get displacement given acceleration, right? Okay. Given A. Okay, so we have in this one, we have V0, right? We have time. We have acceleration. I'm an efficient programmer, so I don't type things over and over again that I don't need to. Right? So how do we do this calculation? We do what? V0 times time plus 1/2 is what? 0.05. It's probably easy to type. Times A times T times T, right? Oh, did I call it T? I called it time, didn't I? Yes.
Can you put time and time in parentheses together? Because they have to square each other first. Is that not a thing?
Well, we don't.
It just messes with my head really
It
bad.
messes with your head. We could put them in parentheses, so that's one way. Another thing we could do math.pow, right? So we could take time to the second power, right? Is that better?
Yeah, that makes me feel better.
Makes me feel better. It looks right. Right, and we actually shouldn't have any problems with this because if you look at where our plus is, right, we do our multiplication on both sides and don't worry about that. Okay?
Do you ever wonder if you have like a fraction to keep this accurate? Because like some fractions like 1/9 are repeating.
Yes, there are fractions that are forever repeating and cannot be validly represented. So
Would you just put it like in parentheses and divide it? Like 1/9.
could you do that? Technically, but we don't want to reinvent the wheel. So there is such a class. Let me think of what that one's called. Big. It's a big decimal. Yeah, big decimal. So you can use the big decimal and the big integer. So basically, what they do is they keep all of those fractions for you forever and forever until you go and convert it at the end. Right? So basically, they store all of that information of what's the numerator, what's the denominator. It'll, I think, do simplification of them, but it'll store as many decimals as you, right, as many numerators and denominators as you have, right, and keep all of that in there. So that is one, but it uses a lot of space, right? So if you take some really big number like 1 over a quadrillion, right, that actually stores the string, generally 1, and then a quadrillion on the bottom. So, and that's just quadrillion. You could pick, you know, a billion zeros. Well, that's going to take up a lot of space. So when it, for all intents and purposes, becomes 0. So there are classes that will do that, and there are times where you want to do that, like big integer, right? We'll store integers again that way, and so you can multiply really big integers, and it does all the math on the back end because it actually has to take parts of it, like take the bottom 32 bits and multiply it by another 32 bits, and then you do this cross multiplication and you add them together, and somebody figured out how to do that. So that's a good question. All right, so velocity 0 times time plus 1/2 at squared. So let's do this one. Okay, so one thing I want to show you guys is that we can actually, so if we go over some of these methods, right? If you hover over it, I think this works in whatever that thing that you guys use. What's that called? IntelliJ. I think it does this stuff. Like, it's probably smart enough to figure it out, right? So we can actually define what this stuff here, right? This is actually just done inside of the Java class. And it's called Java Docs. So let's just do one here. I think it's 2 asterisks. There we go. So mine automatically filled it out. We'll see if your editor is smart enough to do that. But you can do that too, right? So what you can do is you can type whatever it is you want in here. So get displacement, right? It automatically added these, right? The at params to mean these are the set of parameters that you gave inside of here, right? It figured out, it knows what they are, right? It knows that we return something. And so if I have one called get the displacement, and I add this Java doc to it, oh, do I need to save? Let's see. Come on. Oh, maybe I added one too many asterisks there. No? It's gonna, oh. Oh, I broke it. I think this is the right way. I was hovering over the wrong one. And it won't give it to me. Let's get it here. 0. See if I can get it to work. There we go. Right, so if I add this information to the, what we call Java docs, right now all of a sudden, when I hover over it, it tells me information about that method. Right? So now you too can look just as professional as all of those APIs. And you could say, here, the initial, and then when you hover over it, right, you get all of that information, right? Here are the parameters. And then you could put in stuff about what the return does. Return the and then when you hover over it, right, it does all of that for you. Right, so if you're on a large project, adding Java docs is something that can be useful. If you're on a project that is sort of open, right, and anybody can use it. So, for example, if you write some cool app in this class and you want to share it with the world, there exists this thing called GitHub where anybody can post anything. You can make public projects, you can make private projects. Because you're students, they'll allow you to make some. And you can publish your code, right? And anybody in the world could end up using your code. And so if you do that, you probably want to put stuff like this in so people know how they're supposed to use the methods that you made inside of your code. Now, I used to have professors that were very strict on the fact that we had to do lots of documentation of what our methods did, and it was probably a different time back then. So I actually worry less about documentation, and I go by the philosophy that because code changes so quickly these days, that adding documentation is only going to, what we call, get stale. So I'll add documentation and say, hey, here's how I did it, right? And then I go back and I change the code. And I keep changing the code because I have a bug. And I don't go back and update the documentation. So now all of a sudden you have documentation that says one thing and code that does something different. So my philosophy is, and when I work, this is what we did, is that only add documentation if something is weird. Right? So if, like, oh, you have to do this because this API is broken, and so you always have to pass in 0 or something. Or if there's some weird constant that you have in your code. You're like, okay, here's why I have to do this. So I generally am of the philosophy that you only want to put documentation in when there's something that you need to know that is important to what you are doing. So that's the way I look at it. So I don't make you guys do documentation necessarily. I don't think you have to do that in labs, but other professors have a different feel for that. So, all right, so we got our displacement. So let's say we fall for, we'll do 2 seconds here. And I use my variable because I'm an efficient programmer, so that's awesome. And I didn't put any stinking new lines in. So this all runs together. Let's try that again. So if I drop something, right, at initial velocity of 0 and let it fall for 2 seconds, given gravity, it will fall 19 meters. Okay? All right. So any questions on writing methods? Again, we did all sort of very similar methods. I'm hoping maybe this kind of gets you into the fact that we're going to be using methods. We want to break up our programs into methods. When we talk about validating user input, so we're going to talk about the next chapter that we will talk about will be on loops and how we repeat code. Right? So one of the first things that we're going to do is we're going to write a method that gets valid input from the user regardless of what they do. So we want to read an integer and they're like, Bob, 10. And you're like, no, I said an integer. You're not listening. You are hearing, but you're not listening. Right? And so we're going to do that. So that way we make our programs so that they don't break, right? Because having our programs break is not cool. And I think today we're not going to do news stories because, well, I didn't have time today and I was gone on Monday. So, sorry, no news for the day, no jokes for the day. All right, so that's it for today. I'll probably post another homework. It probably will be due next week or the week after. So.